Hey everyone, Mr. Andrew here. Today I wanted to talk to you about covalent bonding. Now, today we're mostly going to be focusing on just what covalent bonding is, why does it happen, and what are some of the different types of covalent bonds. So, covalent bonds are bonds that form when atoms share electrons. So, to kind of compare and contrast covalent and ionic bonding, we talked about ionic bonding before. Now, ionic bonding happens when one atom gives an electron to another. And when that happens, both become charged and they become oppositely charged and they stick together. But the critical part is that ionic bonding happens when electrons are donated. From one atom to another. Okay. Covalent bonding Covalent bonding, on the other hand, is when electrons are shared between two atoms. And this is the key difference between them, because in the first one loses and one gains. The other one, covalent bonding, they're both sharing those same electrons. Now, let me kind of explain this to you a little bit more in detail, right? So, when we talked about ionic bonding before, we talked about how it has to occur between a metal and a non-metal, right? So ionic bonding is like sodium and chlorine getting together. Sodium loses an electron, chlorine gains an electron, and they become stuck together. But what happens if chlorine doesn't have any sodium around it? So let me just draw a quick Lewis dot structure of chlorine. Okay. Now chlorine, it wants to complete its octet. It wants to uh, it wants to gain an electron to match what the octet rule says. So ordinarily, it would just gain one from sodium and it would be happy. It would complete its octet. But if there's no sodium around or there's no other metals around, it can't really fully gain an electron in that way. So something else has to happen. Chlorine might encounter another chlorine. Okay. So I've got my two chlorines here. Okay. And they're just floating around. Neither one of them is meeting the octet rule. Okay. So because they can't find an atom to donate an electron, what ends up happening is these two chlorines will actually share one electron each. Okay. So what will end up happening is chlorine, this chlorine, for instance, with its electrons, will become stuck to this other chlorine. Now, for the sake of clarity, I'm going to replace the dots on this second one with X's, okay? But just understand that in my model right here, those X's are also electrons, okay? Let me just kind of put this one like this. Okay, so you can see in this second chlorine, I've just replaced all of the dots with X's so that you can see which chlorine has which electrons. So this first chlorine has 7 electrons. You can see the 7 dots around it. And the second chlorine has 7 X's. And these 2 electrons right here in the middle are actually shared between both of them. And so as a result, this chlorine has 8 electrons surrounding it, and this chlorine has 8 electrons surrounding it. So these electrons in between them, which are being shared, actually get counted twice. And as a result of this, both chlorines now meet the octet rule and both become more stable. Now, this is just one way that we can represent covalent bonds in Lewis dot structures. You may also see it a lot looking like this. So this line right here represents a covalent bond, okay? But this line that I just pointed to and these shared electrons over here, those are the same thing, okay? So you may see it one way, you may see it the other, but they are both correct, okay? So because these electrons are being shared, they get counted twice. And so 2 atoms, which ordinarily would not have enough electrons to meet the octet rule, because they share their electrons, they both meet the octet rule and they both become more stable. That's kind of the idea behind this. Okay. Now, there are different types of covalent bonds. Okay. There are what are called single bonds. Okay. Actually, let me clear some of this off. Okay. So there are single bonds. That's when 2 electrons are shared. Okay. And an example of this would be the one that I just drew, this. Okay. You can see that there's 2 electrons being shared between these 2 atoms. Okay. There are double bonds. That's when 4 electrons are shared. Okay. And actually, I'll draw the other version also. Okay. So an example of a double bond would be something like when oxygen binds to another oxygen. Something like this. Okay, so you can see now there are 4 electrons being shared in between. And as a result, they're both meeting the octet rule. There's 4 being shared, and each one has 4 on their own. Okay. You may also see it look like this. Oh, actually, I had the X's on this side. Let's try and keep it consistent, Mr. Andrew. Okay. And lastly, there are triple bonds. And unsurprisingly, triple bonds are when 6 electrons are shared. So an example of this would be keep trying to do that one first. Nitrogen bonding with nitrogen. So nitrogen has 5 valence electrons right here. So you can see there's 5 dots and there's 5 X's. But because their electrons are being shared, that one has 8 around it now, and this one right here has 8 around it. Okay. And you may also see it look like this. Okay. So when you are drawing these, you can use either of these methods. Both are considered to be acceptable. It's really up to you. Okay. The important thing is keeping track of the number of electrons you've got and making sure they're in the right spots. But that is for another video. Okay. So covalent bonding, just to recap it, are when electrons are shared between two atoms. And when this happens, these atoms become more stable because they can kind of get around the octet rule a little bit. Because effectively what's happening is the electrons that form the bond are counted twice. Okay? So single bonds are when 2 electrons are shared, double bonds are when 4 electrons are shared, triple bonds are when 6 electrons are shared. So with that, that is the basics of what covalent bonds are, and I will see you next time.